This is our third lesson on verifying trig identities. These 5 steps are here just to remember. You may want to pause and just look at them again. And we're going to go through some more practice problems. So what we're going to do this time is verify this first example. 1 plus the tangent of x plus the tangent of x equals secant squared of x over the tangent of x. All right, I'm going to start with this left-hand side. And notice I have a 1 over the tangent of x. I'm going to try to get like denominators. So right now in the second term, I have the tangent of x over 1. If I want to get these to be alike, I find the greatest common denominator, or the least common denominator, and so I'm going to multiply it by the tangent of x and the tangent of x. And I'm leaving the right-hand side of the equation alone. All right. So this first, 1 over the tangent of x, I'm going to leave alone. Over here, the tangent of x times the tangent of x is tangent squared of x. And then 1 times the tangent of x is the tangent of x. So now I have like denominators. These two fractions are alike, so I can go ahead and combine them into one fraction. So I add across 1 plus the tangent squared of x over the tangent of x. All right, so I've combined it into one fraction. Now I look to see if I have any identities. I do have an identity right here. It's the Pythagorean identity. Look at your sheets, find your Pythagorean identity. So this can be replaced with the secant squared of x. And then I still have the tangent of x in the denominator. I have not changed that. All right, let's head up to the problem and see if we verified it. So we head up. This is what we wanted. Bring it all the way down. We wanted the secant squared of x over the tangent of x. Here's a second example. We're going to go ahead and start with the left-hand side. And we're going to convert this to all sines and cosines of x's. So I'm going to start off with this tangent of x. This tangent of x is the quotient identity. The quotient identity is the sine of x over the cosine of x. Then this guy here, the cotangent of x, is the same thing as the cosine of x over the sine of x. All right, so what I have is two fractions. They're not alike. So I'm going to try to make them alike so I can get one term. So I look at their denominators. The denominators are not alike. So I'm going to start off with the first fraction, and I'm going to multiply by what I'm missing. I'm missing the sine of x. So I'm going to multiply the numerator and the denominator by the sine of x. Heading to the second fraction above here. I don't have the cosine of x in the denominator because my LCD, least common denominator, is the sine of x and the cosine of x. So I'm going to go ahead and multiply the numerator and the denominator by the cosine of x. All right, so now let's simplify that. So when I multiply fractions, I multiply across. So the sine of x times the sine of x is sine squared of x over, and then I have the cosine of x, sine of x, plus multiply across, cosine of x times cosine of x is cosine squared of x. And then I have the cosine of x times the sine of x. All right. These two fractions are now alike. I can go ahead and combine them into one fraction. So I add across. I have the sine squared of x plus the cosine squared of x over my least common denominator, cosine of x, sine of x. All right. Hopefully you're now getting to recognize the Pythagorean identities. That's this one right here. The sine squared of x plus the cosine squared of x is the Pythagorean identity. Check out your sheets. Sine squared of x plus cosine squared of x equals 1. Now in the denominator, we still have the cosine of x and the sine of x. All right. We're getting there. We look up. We want the secant of x times the cosecant of x. The secant of x and the cosecant of x. So what I'm going to do is I'm going to separate out these two fractions as 1 over the cosine of x, and then 1 over the sine of x. All right, these two are the reciprocal identities. 1 over the cosecant of x is the secant of x. 1 over the sine of x is the cosecant of x. All right, let's see if we verified it. So we head up to the top. We wanted secant of x times the cosecant of x. And we got it. Secant of x times the cosecant of x. We verified it.